Let me refer you to your notes on distance formula. The distance formula does tell us the measure of a line segment. Here I have two endpoints. Perhaps this is part of a rhombus, and the directions are asking you to find this side of the rhombus. Just tell the distance from one point to another. Perhaps you'll need that in order to work the perimeter of that shape. At any rate, the distance formula is going to give you that calculation. We're going to be using our two ordered pairs, and those would be the endpoints. So we have to signify one as maybe this could be our first point, and perhaps we'll use this as our second. It doesn't matter, it's your choice. And then we're going to populate our formula. So the distance is equal to the square root of x2. Okay, I'm going to go to my second point and put in my 2. And then subtract the x from my first point, which is -1. Now that's a -1. This mark is already, this subtraction mark is in the formula. So I'm going to just parenthesize my -1 so I don't get confused when I do the calculation. And this quantity then is squared. Moving on to the y portion of the second point, 6 minus 2. And that quantity is squared. Distance is equal to. All right, in this case, I have to pull back my rules for positive and negative. I've got two signs that are the same. So that changes that 1 to a positive. So now I'm going to do a copy job with the 2. This is I incorporated the rules for positive and negative to make it positive, 1 squared. And this one is just simply a copy job at this point because there's nothing going on. Distance is equal to the square root of 3 squared plus 6 minus 2 is 4 squared. D is equal to 3 times 3 is 9, and 4 squared is 16. D is equal to 16 plus 9 is 25. The square root of 25, that's a perfect square. We can branch this to 5 times 5. And remember, when we factor underneath a square root sign, we're looking for pairs of numbers that are the same. So here I have two prime number 5s. So one of the 5s comes outside of the radical sign to represent the pair. So the distance in this case is equal to 5. From point first to point second, we've got 5. Let's call that feet, 5 feet. I didn't put the label onto that, but that's reasonable. All right, so that is showing us our distance formula. Now, if that were a regular polygon, all of the, let's say it's a regular quadrilateral. So a regular tells us that all the sides are the same. At this point, we could do a perimeter of that fictitious shape. Now, moving on from this part, we can also find the distance to the midpoint, some point that's between the two endpoints. We could use the distance formula for the midpoint. Check your notes. It's the same, starts out the same way, except all of this then is divided by 2. So our formula would be the distance formula that we used before divided by 2. So all these calculations are the same until you get to this point, and then this is finally where the 2 kicks in because we've divided by 2 on all of it. as we're just carrying it along. But order of operations say we don't do anything with it until now. And then this would give us 2 1/2. So the midpoint, from the midpoint to the end point, would be 2 1/2. And from this midpoint to this end point, this would be 2 1/2. Well, that makes sense because 2 1/2 plus 2 1/2 gives us the whole segment. So our distance formula gives us the distance between the endpoints, and the distance formula to the midpoint tells us how it is to the middle. While we still have this grid in front of us, we could tell the exact point on the graph of the midpoint if we use this formula. Again, check your notes. You wrote them down before. So this tells us the ordered pair of this midpoint. Again, we're going to use our values for our first and second endpoint in order to populate this equation. So x2, I'm going to be taking it from this one, is a 2 plus a -1 divided by 2. And the y2 would be 6 plus the y value from the first point divided by 2. Our positive and negative rules, here's 2 signs in a row. They're different, so it's going to change the 1 to a negative. 2 minus 1 over 2. 6 plus 2 over 2. Our calculation, 2 take away 1 is 1 and 2. So 1/2 and 8 halves. 1/2 is our x term, and 4 is our y value in that ordered pair. So let's see how close I came with this. We're going to take our 1/2 value over here and move up 4. So it's 1, 2, 3, and 4. That was the halfway mark. And that value is 1/2, 4. That's the address, if you will, of the midpoint.